Oh, wait, hang on a second. This thing says Wednesday. Give me a second. Well, anyway, good morning and happy Friday. I appreciate you guys being here. As you can see, if you're looking at the Zoom, we're missing quite a few students. I think there's almost 80 enrolled at the beginning and some have dropped off, but I appreciate you guys being here. And again, I appreciate anybody who turns on their camera. I know it's like, it's not fun and you feel a little bit awkward, but it is nice to see people's faces, and I appreciate that, and it does make a difference for me. And you know, I also I hope I'll be able to recognize who my students are when we're back in person. So so the school has released some guidance on how basically that they're going to give the professors the option to choose what they want to do. So so I will start teaching the class in person on January 31. So that January 31 will be our first Monday after January 28th, which is kind of the period for which we are mandated to be online. But starting January 31, I will begin teaching the class in person. So, you know, we'll be live at 9 a.m. on campus. I will continue to record the lecture and I will continue to post them online. And I will continue to use view quizzes to kind of encourage people to either attend or view the content. So if for whatever reason you can't come in person for the lecture content, you should still be able to keep up with all of the material and things of that nature. My office hours, I will continue to hold the kind of the same sessions. It will just be that Monday and Wednesday office hours will be kind of this hybrid in-person online business. And depending on how, well, at least the Monday and Wednesday at 12:30 to 1:30. Wednesdays at 5 o'clock will be online only. I think I've got this all listed on the office hours schedule. And, you know, I'm not quite sure what hybrid office hours, how that will go, but just, you know, be patient and flexible. If you're online and you have to wait, or if you're in person and you have to wait for me to finish talking to someone online. So, but that's how that will go. Do we have any questions? No, not at the moment. Okay, let me, I need to convert Jupyter, convert 2 slides, dictionaries.ipynb. Okay, that's good. Let me check status. Let me add that. Slides. Okay, so if you are wherever you are, you can do your git fetch upstream, git merge upstream master, and your git push, and that will get you all of the new content for today. So sorry, let me just check over here. I don't know if I don't think I ever mentioned this, but one nice thing about running Jupyter Lab is, you know, you can open up terminal windows, right? So so from the launcher, you can open up a terminal window or things like that, and you can access and run a lot of this stuff, which is nice. Okay, so now it's updated. Now it says week 3 Friday. So happy Friday, and yeah, today we will talk about dictionaries. So dictionaries is another structure. We had discussed libraries earlier, or not libraries, lists on Wednesday, and today we will talk about dictionaries. So dictionaries are a mutable structure, a lot like a list. And list items, however, you can access them by their position. Dictionary values are accessed by their keys. And technically, well, no, yeah, dictionary items you access via the keys. Okay, so dictionaries are mappings of keys to values. And so the most common way to kind of create a dictionary is by using curly braces. Okay, so when you see curly braces in Python, this means we're making a dictionary. You know, in R, curly braces are used to kind of group lines of code together. In Python, we just use indentation, and we can use the curly brace for a different data structure. So we're going to see a curly brace that's going to be for dictionaries, and then you're also going to see colons to associate the keys along with their values. If you want your keys to be strings or characters, you need to enclose them with quotes. All right, so here here's a dictionary. I'm creating a dictionary called people. I've got 3 items in my dictionary. We've got Adam, we've got Bob, we've got Carl as keys, and the values look like numbers. They look like ages maybe. So Adam's 25, Bob is 19, or Carl's 30, or maybe it's how much money they have in their pocket right now. Who knows? Probably their age and years. Okay, and then so we've got people listed here. Something happened here. Okay. If all of the dictionaries are simple strings with no spaces, that is, you have things like Adam, Bob, and Carl, and not something like Adam Smith, or something where where you might have a space in the name, you can create the dictionary directly using the dict function. Okay, and notice here I'm doing Adam equals 25, Bob equals 19, and Carl equals 30. Okay, so this is probably, I would say, curly braces, I don't know, might be one of the easiest ways, just because this is recognizably a dictionary as soon as you see it. Okay, but that's going to be using colons. Whereas when you kind of create the dictionary this way, it's the same, but you're going to be using the equal signs and things like that, and you get the dictionary right there. Okay, there's even more ways to create a dictionary. You can create a zip object and then turn it into a dictionary. So if you have, say, 2 lists of the same length, you can zip them together. Okay, so this so it's kind of like the idea of using a zipper. And so here you've got a list here and a list here, and then when you call zip on it, it creates a zip object. And basically this is a address location. So this is the location for the object in memory, right? So when you see zip at this, remember, all Python objects, variable names are pointers to an object in memory. So this has created what's called a zip object, and it's located at this address in memory. And what we want to do, maybe we want to turn it into a dictionary or something. So we can call dictionary on the zip object. This would probably create a new zip object, but we can call dictionary on the zip object, and we get the dictionary. Okay, and basically the reason why when you call zip and you get this thing rather than a dictionary directly is, there's other things you can do with a zip. You can kind of iterate over it and things like that, and you might not necessarily want to spend the overhead of converting the entire zip into a dictionary. So, so this is another way to create a dictionary. You can also create a list of key value pairs. So here is a list Okay, so I've got square brackets here. And within this list, I have tuples, or I could have other lists. Okay, so here I'm using parentheses or curved braces, not square braces, where I have a key and a value, key and a value, key and a value, right? So I think one of the early examples in the lists, I had fam and fam2, and fam2 looked like a bunch of kind of key value pairs. We had the name and their height of Liz and dad and mom, and their height in meters or something like that. That could be turned into a dictionary just by wrapping dictionary around it. Okay, and so when we do that, it turns the list of key value pairs into a dictionary. So these are all ways to create the same thing. Okay. I guess it just occurred to me that maybe not everybody is aware of the files that I've uploaded. So into GitHub, every lecture is turned, there's 3 files. So there is the IPython notebook that I create, and this is kind of how the slides are made. And then I use Jupyter Notebook Convert, NB Convert, to make the slides that I use. And then I also have a PDF of everything in case you want to kind of go through it with the PDF. It's just, the PDFs end up being like 100 pages long, but some students prefer having a PDF. So I've done that as well. Okay, anyway, yeah, so if there's any kind of line of code that you want to test out, you can open it up and you can say, well, what would happen if I change this to 31 or something? And you can see exactly what would happen. Okay, or actually what I would recommend is I would, if you want to make changes to it, I would run duplicate and make your changes on the duplicate. Okay, and actually over here, let me reset. Okay, good. Wait. Okay, yeah, reset to what we have. Okay. Okay, so how do we access? So once we've created the dictionary, how do we access these? Okay, you use square brackets and you put in the name of the key. So here I've got, I've got this dictionary, and all of these dictionaries, people 1, people 2, people 3, people 4, they all look the same. So if I just do people and I put the name Bob in there, I get back the value. You can also use the get method, people.get, and you put in the name of the key, right? So you put in the name of the dictionary, .get, and then you put in the name of the key, and you get the value associated with it, okay? If you ask for a key that doesn't exist using square brackets, you will get an error. So you'll get people, square bracket, Joe, you'll get back an error. Whereas if you do people.get, so this is the difference between using square brackets to get access the key and using .get. So if you give it the name of the dictionary .get, and then you put in, if you put in a name that doesn't exist or a key that doesn't exist, it returns none, which in general doesn't get printed out, right? So when it returns none, generally no output appears, but here I called print. And so when I call print on none, none appears onto the screen. Okay. You can provide a default value. So you can say get Joe, and if you don't find it, it will return kind of a default value for any key that it doesn't find, and you'll get back a 0. there's a question. So typically with methods, will they return none if there is no output for the command? Yeah, if there's, well, it depends on the method. So some outputs, so some methods will return none and some will return errors. So for example, like with a list, if you ask for find, it will, and it doesn't find it, it'll return -1. If you do list.index, it'll return an error. So it all depends on the method itself. So not everything is going to do this. Okay, are dictionaries one-to-one? Meaning, can I have an entry like Joe :25:3275? And the answer is they are one-to-one. You cannot have two keys go to one value. Okay, you can have it's one object as a key goes to one object as the value. Now, you can use a tuple as a key, a tuple containing multiple values. And you can have a value, and for the value, you can put in a tuple or a list or something with multiple items in it. Okay, but the key and the value have to be a one-to-one match. Okay, but inside the value, it's an object. It's any kind of object. So you can put in, so that object could be a list with containing multiple items in it or things like that. But there's one key and one value. Okay. I guess this slide talks exactly about keys and values. So dictionary keys have to be immutable objects. Immutable, right? Remember, immutable means we cannot change it or update it. So what does that include? That includes strings. So strings are immutable. Anytime we tried to make a change to a string, it always created like a new copy of it, right? You do string.upper. It's not modifying the string. It's creating a new object that's all uppercase of that string. So strings are immutable. Numbers, which are, integers and floats are immutable. And tuples are immutable. Even functions could be a key. It's a little bit strange to think about that. But tuples are like lists, but they are immutable. You cannot append to a tuple. You cannot just change one of the values in the tuple. Okay. Dictionaries are not allowed to have duplicate keys. There are no restrictions on what can be a dictionary value. Dictionary values can be any object, but again, just one object though. And that object can be lists, it can be tuples, other dictionaries, other functions, things like that. Okay, so here I am creating a dictionary. The key is 1. The object is the function length. Here I've got a key 3 and the value is a dictionary. I've got a key 4 and the value is a tuple. I've got a key 2 and the value is this list. Okay, so I can say what is the item with a key of 1? Okay, I'm not asking what is the first object or the one index object. Okay, notice this is the key. The key is this number 1. And so it comes back and says it's the function, the length function. Okay, what is the item with key 2 or the value associated with key 2? Okay, it's this list, 20, 4, and 5. All right, so maybe Savaji, your question, perhaps if you wanted multiple things, maybe you can have the key be the name Joe, and then you have a list with multiple items, such as the age and ID number or whatever it might be. Okay. Question, what happens if I have 2 of the same keys? Okay, for example, Bob 25 and later on Bob 53, as if there were multiple Bobs. Will Python just throw an error? Well, it will. It reads the code left to right. And basically, if it starts off with Bob 25, and then later on, when it encounters Bob 53, that 53 is going to overwrite. It's going to see it as like you're updating the value stored for Bob. Okay. If you have multiple people named Bob, you got to use something, you got to call this like Bob Smith and Bob Jones and Bob whatever. Okay. You can't have the same, it's like the Motion Picture Academy, right? Every actor needs to have their own thing. So here, let me just kind of show you. So here, if I did dictionary and we do Bob 20 and then 30, and then I go back to Bob and I do 50. Okay. Let's call this X. And let's print out X. Okay. So you can see it reads it left to right, and then later on it encounters Bob 50, and that just overwrites what we've got going on here. Okay. Here I ask, what is the object associated with key 4? And it gives me back the tuple. Lists can be values in a dictionary, but they cannot be keys. Okay. So only immutable objects are hashable. So mutable objects like lists or dictionaries are not allowed to be used as keys. So here I've got L using square brackets. This is a list. T using the curved braces. This is a tuple. I'm going to start off by creating an empty dictionary. Okay. And so if I try to say make, use L as a key, right? So you can actually use, I didn't actually show this, but you can use the kind of the way you would select a key and along with assignment. And here we would say, you know, let's try to assign the value won't work to a dictionary here, to a dictionary with this key, the key being 1, 2. That doesn't work. Okay. But I can assign a value to the tuple. Okay. So the tuple 1, 2 is considered hashable. So if you're in this situation where you've got Bob and you've got 2 different Bobs here, okay, let me copy this. Okay, what you can do is you can use as the key, you can use a tuple consisting of maybe the first and the last name. Okay, and then so here I can create a tuple. I've got Bob Jones, and then we'll call this Bob Adams or something like that. Okay. And now I've got this, and then I can ask what's associated with Joe. Whoops. Oh, there's no Joe. Jim. So Jim, we get 30. And then, you know, if I ask X Bob, I get back an error. Okay, there's no key Bob now, but I can ask X Bob, and then I put in the tuple. Okay, and that finds it just fine. All right, I don't know if that answers your questions. Okay. Oh, you know what? I'm getting ahead of myself. Let me give you your first view quiz answer, and I got to start picking up the pace. Today's first view quiz answer is C. C as in cat. C as in cat. Oh, by the way, I've posted a new homework assignment and also some data camp homework. The data camp homework is due 1 week from today on Friday, and the assignment is also due 1 week from today on Friday, January 28th. Also on data camp, we're going to start entering the grades. Please make sure you've updated your name on data camp. So you go to your account settings, your account profile, just make sure you've got a first and last name in there. There's a handful of students where it's just the email address, and it just makes it a pain to try to figure out who that is based on email addresses. I mean, some are clear and some are not. Okay. Again, oh, here's the thing. Python will not produce an error if you create a dictionary with duplicated keys. Only the last instance of the key will be stored because it's basically encountering it and just overwriting everything. It's like updating all of the values. So here I've got A is 1, B is 10, A is 2, B is 0, A is 3. We're going to get the B0 and the A3. Okay, and then when we ask for B and A, we get 0 and 3. Okay, dictionaries are not indexed by position, so you cannot use numeric indexes. If you provide a number, that number would need to be a key in the dictionary. So here I've got this dictionary. I cannot ask what is the 0 index value. Okay, I cannot ask what's the 0 index value. And they've actually updated Python. Dictionaries used to not be ordered at all. There used to be no order whatsoever in a dictionary. But now dictionaries will retain their order, but again, you still cannot ask. You still cannot ask for something by position. Okay, so you can't ask what's the 0 index value. There's no 0 key, so you're gonna get back a key error. Okay, and this is whenever you see key error, it means you've done something wrong with your dictionary. You've asked for a key that doesn't exist. So again, pay attention to the errors that Python writes out. Okay, you can't slice dictionaries the way you would get with a list. When you use a dictionary, you only get one value back at a time. Okay, so if I try to say 0:2, we get something back. If I try to say give me everything from Adam to Carl, it says no. Okay, so this says you're giving it an unhashable type. It's looking for a key, okay, that matches Adam: Carl, except Adam: Carl, you know, it's just you can't do that. Okay, what you can do though is you can ask if a certain key exists in there, right? So if you want to check the existence of a value, you can use the in operator and it will check for the keys. Okay, if you want to check for the existence of a value, like is the number 30 one of the values, you have to use dictionary values. So is Adam a key in people? Yes, we get back true. Is 19 the number 19 in people? Again, this has to, 19 is a value, and the in operator only applies to keys. Okay, is there a key in people 19? No, but is 19 one of the values in people.values? That is true. Okay, so so we have that. Okay, the one of the things for about Python and dictionaries, like why we like dictionaries so much, is that the operators like in and things like that use completely different algorithms. So if you have a list and you ask, is Adam in your list? And let's say it's a really long list, okay? Computationally, the computer starts at the 0 index, your first element, and it goes through and it looks, is this in here? Is it in here? Is it in here? Is it in here? Is it in here? And it goes down the list. And so if you have a huge list, a list with like millions of items, this could take a long time. This could take your computer a long time. The dictionary has kind of this hash table that basically almost like instantaneously you ask, is this thing in here? And it does something, and basically and it gets back an answer immediately. Okay, it gets back an answer immediately. I'm not immediately, but it takes the same amount of time whether the dictionary has 2 items in it or a million items in it, using this hash table. So the in operator is absolutely fantastic for speed. Okay, let's say you want to add items to the dictionary. Okay, all you have to do is you can just use assignment, right? So the way you would access, right? The way we would ask for one of the items, if I didn't put in this equal sign, it would retrieve the item. But if you use it in conjunction with assignment, it's going to create new entries or update existing entries. Okay, so here I say Derek 33. Derek 33 now shows up as a key. Okay, Adam equals 26. We're now updating the key value pair to have the value 26. If you want to remove a key, you use delete. Okay, you use del, people Carl. All right. After that, Carl is gone. So I think for our users, we're not used to seeing something like del, but that's a real thing. That's a real thing. Okay, we delete keys from a dictionary. You can also use del on lists and stuff. We've got pop. Okay, so just like a dictionary, you can pop things. But when you use pop here, it's going to remove the key. You have to provide it a key. Okay. If you call pop without providing a key, you get an error. Again, you have to think of the dictionary as not having an order. Okay. So if you think of it more like a bag, right? Or a backpack. And if I tell you, you know, there's 7 items in the backpack, remove the 7th item, take out the 7th item. That's confusing, right? Because when you look inside a backpack, there's no order to the objects there. Okay. And so you have to provide a key. You have to say, all right, remove the pencil, remove the book. Okay. So here we can say pop the value associated with the key atom. Okay, we say pop atom, and it says, hey, the value is 26. Okay, and then the dictionary no longer has that. Okay, you've popped it out. Okay, it returns the value associated with the key, and then it shrinks the resulting dictionary. Okay, if you've got lots of values to add, keys and values to add to the dictionary, you can use update. Okay, so you can update it one at a time in the way we did it with where did it go? Derek back here, right? So we can add one value, or we can update it one value at a time using this. Okay, people new key with the new value here. Here I've got a dictionary, Adam, Bob, Carl, Dave, Earl, Fred. Okay, and we can say take dictionary A, people A, people A, use the update method and update it with additional keys from people B, keys and values. And so when I do this, now we have a big dictionary, or people A now has the original values, Adam, Bob, Carl, along with all of the kind of updated values that they're doing here. So if you've got 2 dictionaries and you kind of want to combine them, you can use update. All right. If new values come in, okay, if the dictionary used to update has keys that exist in this first dictionary, the keys in the first dictionary will get overwritten with the updated keys, right? And so this is why we call it update. You can't just, and there's no, with a list, you can do a plus operator and it just kind of sticks the 2 lists together. We can't really do that with a dictionary because everything's kind of done with keys. And if we run into this issue would say, here I've got Fred 27, and in people C, I've got Fred 99. Which one takes precedence, right? If I do people A, update with people C, then we'll get Fred 99. If I had flipped it around with people C, update with people A, then we would start with Fred 99, Gary 18, and then we would update. If I did, instead I did people C, update with people A, then we would add on all of these things, and then Fred 27 would overwrite Fred 99. Okay, but here I asked update, and now Fred shows up with 99. Okay, and Python or IPython is recognizes when if it tried to print the whole line, it's going to run out of space, and so now it reformats it to print vertically. Okay, so even though this looks different, it's the same exact structure. It's just it's run out. It recognizes it's not going to be able to fit Gary 18 over here, so it starts printing it vertically over here. Okay, dictionaries have what are called view objects, and these are dynamic view objects. And so that means the values in the view object change when the dictionary changes, okay? Your view objects are .keys, .values, and .items, whatever name of the dictionary you have. So again, here I'm going to create my new dictionary, Adam, Bob, Carl as keys. And here it is. And I can just say, hey, let's take people.keys and we'll call that names, people.values, and we'll call that the ages. Okay. And so right now the names are the keys, Adam, Bob, Carl. Okay. Let's, and the ages are the values, 25, 19, and 30. And it clearly tells you that these are the keys from the dictionary keys and dictionary values. It doesn't come out as a list or anything like that. It says these are dictionary keys and dictionary values. Okay. I'm going to create a new key value pair. I'm going to say Ed is 40. And without having to redefine the object names, dictionary keys now has the updated information. It now has Ed as an entry in dictionary keys. Okay. And ages now has 40 as an entry here. Okay. I didn't update this. This is a dynamic view object. And whatever is happening to the dictionary keys shows it. Okay. I didn't have to say, hey, look up the keys again, or look up the values again. These are view objects. They are dynamic. They update on the fly. Okay. View objects really only support a couple functions, such as the length and in. Okay. If you need to do something more with a view object, okay. So again, you have to think of it as like you're taking a look at it, right? It's like you're looking through a little telescope or something. You're just looking at it. You don't really get to modify stuff when you're just looking at it. And you need to do more. You can convert the view object into, say, a list or some other iterable type like a tuple, but then you're basically creating a copy and it's no longer dynamically updated. Okay, so so right now ages is a view object, and we can call length or in on ages, and those work. I can take ages and I can convert it into a list. Okay, and now I can work with the age list. Age list has 4 items in it, and I can work with the values. I can do any of these things. I can take the dictionary. I'm going to add a new key value pair to the dictionary. And while the dynamic view object for ages updates with the new age 29 in here, the list that I created in the previous step, okay, where I created list on the ages at this current point in time where there were 4 items, that remains unchanged, right? Because this list is basically a copy of the items that were in the dictionary view object at the time, which were these 4 items. And it's no longer dynamic, so adding new entries doesn't give me, doesn't do anything here. Okay. View objects, again, you cannot subscript them and ask like, what is the value? What is the 3 index value? That's not going to work. You can't even ask what is the value associated with the key Bob, because as far as dictionary values go, there's no keys. There's no keys anymore, right? We're just pulling out the values. The view object only has the values. So we can't ask, hey, you know, what's the value associated with it? You just use the dictionary. Just use the dictionary there, okay? And then if you ask for the other view object is dot items, okay? Dot items is basically going to be a view object with a bunch of tuples, a key value pair. And again, you can turn this into a list of tuples. This one up here, the view object is dynamic, whereas the list is not. Let me go ahead and give you your next view quiz answer. Today's second view quiz answer is B. B as in bear. B as in bear is your second view quiz answer for today. B as in bear. All right, so here are a couple cool things you can do with dictionaries, right? So one is you can say you can use a dictionary as like a collection of counters, right? So let's say you've got a big string. You want to count how many times does each letter appear, right? How many times does the letter A appear in this? How many times does the letter B, right? There's a few ways we can do this. One, we could create 26 variables, one for the letter A, one for the letter B, one for the letter C, and then we can kind of create some kind of for loop that goes over the length of the string. And for each character that we find, we can update the corresponding counter, right? So we can say if it's A, add 1 to A. If it's B, add 1 to B. If it's C, add 1 to C, right? That sounds a little painful, right? One is we can also create a list with 26 elements. And then we can take convert each character to a number using kind of there's a built-in function called order. And then we'll use the number as an index into the list and increment the appropriate counter. So we can kind of ask like, the first character in the string is the letter C. And we can ask, okay, where's the kind of the position of C? And then we can, using, C dot order dot C, we can do that. And they'll say, oh, it's the, index 2. And then we can update, add 1 to the index 2. Or lastly, we can use a dictionary, right? We can use characters as keys, okay, right? Strings can be the keys. And counters, they're all going to start off as 0 as the values. And the first time you see a character, we would add that item to the dictionary. And after that, we would increment the value of an existing item. So using the dictionary approach, this is kind of what it would look like. So here's a function. We're going to call this histogram of basically characters. We're going to start by creating an empty dictionary. And then we're going to traverse the string using a for loop. We're going to say for each character in the string, okay, if the character is not already a key in the dictionary, is what we're saying, right? If the character is not already a key in the dictionary. And this is one thing I love about Python, is it feels like you're just reading English, right? It's this very kind of just plain language thing, right? So if the character is not already a key in D, then, well, let's create that character key. So we're going to have D character, and we're going to just set it equal to 1. Okay. Otherwise, okay, that means if the character is a key in the dictionary, then add 1 to the current value associated with the character. All right. And at the end of the function, return the dictionary D. All right, so here I say run it on abracadabra, okay? So it starts with the A, first time it encounters it's a 1, goes to the B, it's the first time it encounters it, so it starts with a 1, goes to the R, it's the first time it encounters it, so it's a 1. And then we get A again, so we increment it to 2, and eventually we go through and we end up incrementing A 4 more times for a total of 5. And B appears twice, R appears twice, C and D each appear once in the word abracadabra. Okay. You can iterate over a dictionary. And you can say, for each key in the dictionary, print out the key. And I mean, this is silly because we could just call like dictionary.items or something and generate, but we can go through and we can print everything. We can say, all right, and from that, from the dictionary, right? So we're iterating over the dictionary H, return the key. So we can do that, okay? And this is what we have, okay? You can't really count on the dictionaries to be sorted in a meaningful way. I think now they try to keep the dictionary in order, but again, dictionaries, don't think of them as ordered structures, okay? If you need to have them appear in some alphabetical order, you can use sorted on the dictionary. It'll sort by the keys. okay? And so I can write sorted on H, and it will sort the key dictionary based on the keys. And now we'll get A, B, C, D, and R for, you know, the abracadabra letters. Here's another application of the of a dictionary. We can do kind of this reverse lookup. Okay, so dictionaries are designed to return a value when you provide the key. But what if you wanted to find the key associated with a particular value? Okay, that's a little bit harder, right? And we got to kind of perform a search. So what we're going to do is we're going to do, you know, kind of this reverse lookup. Okay, and we're going to say, okay, we've got some dictionary here. All right, this is the result of running abracadabra, count each letter in abracadabra. And we can ask like, hey, what's the key associated with the number 5, or what's the key associated with the number 1, or what's the key associated with the number 3, or something like that, right? So what we're going to do is, if we're searching for a value, we're going to just iterate over all of the items in the dictionary. And we're going to say if the value for that key, going through every item in the dictionary, every key in the dictionary, we can say if the value is the value, return the key. Okay. Otherwise, and that means if we run through the entire for loop and we didn't return a key, then we're going to raise an exception. We're going to raise an error, and we're going to get a lookup error, and we're going to write the message value does not appear in the dictionary. So we're going to try reverse lookup, lookup 2. Okay, it's going to just give us the first entry in the dictionary. Again, kind of going in the order of this dictionary here as it's written. It's going to give us the first entry, and it says it's the letter B. Okay, if we say, hey, what has 4, we get an error because it went through the entire dictionary. It never encountered a dictionary where the value is equal to 4. So it never returned a value. So then a return, it will, you know, exit the function. So it reaches the end of this code, it goes to this line, and then it raises the lookup error. Okay, so what is this raise statement that I've used? The raise statement is how we handle errors in Python. Okay, well, in our code, we told Python to raise a lookup error exception, and there are different kinds of exceptions that you can use. And you can follow this link, and it will have different kinds of exceptions. And you got, you know, the assertion error, attribute error, end of field error, floating point error, all kinds of different exceptions that you can do, and this basically chooses what message appears to the user when they encounter an error. Okay, I've got a few more slides here, but let me go ahead and give you your last view quiz answer. Today's last view quiz answer is C. C as in cat. C as in cat. That's our last view quiz answer for today. Okay, lists. We can use lists as values in the dictionary. So as far as the values go, we can have a list. So let's say we have this dictionary that maps from letters to frequencies. Maybe we want to kind of invert it. So here I've done histogram, and I say, you know, how many times does each letter appear? P-A-R-R-O-T. So P appears once, A appears once, R appears twice, and the other letters each appear once. What if I wanted to invert this, right? I wanted to see what letters appeared 1 time, what letters appeared 2 times, what letter appears 3 times. So in this case, I've got several letters that appear only just 1 time. So what I want to do is I want to invert the dictionary, and when I say which letters appear 1 time, I want to get a list. I want to get a list of the letters that appear 1 time. So what we're going to do is I'm creating a function called invert the dictionary. I start by creating an empty dictionary, and I could have used curly braces, but this time I've used dictionary parentheses. And then we're going to iterate over the original dictionary D. We're going to go for each key in the dictionary, and we're going to say we're going to take that current value, right? We're going to say, all right, find the value associated with this key. And if that value is, and this feels a little bit strange, but is that value a key in the inverse dictionary? And if it's not, well, start by creating a list. Okay, start by creating a key there using the value as the key. And then the first item, make a list with one item in there, and the first item there will be the key, right? Remember, we're inverting the dictionary. The values will now become keys, and the keys will become the values. And then if the value is already a key in the dictionary, in the inverse dictionary, then append, your new key to it, okay? And then we're going to get inverse. So here is, here's the dictionary, which says how many times each letter appeared. And then we can invert it, and we can say, well, what letters appeared one time? What letters appeared two times? And so we've inverted the dictionary there. Okay, that's it for today's lesson on dictionaries. So we will end here. Have a great weekend. We will see you guys on Monday online, and we'll see you then. So have a good weekend.